class, welcome to Lab 3 demonstration. So from my Ubuntu 1804 virtual machine, the first process I will run is ROS core. Really start all of my core processes. Now I could generate a launch file using ROS launch to spawn all of my nodes, but for demonstration purposes it's actually easier to show you all of the individual nodes that I'm running. So the first one I did was ROS core. Now I'm going to establish a link between my Ubuntu machine and the Arduino that's behind me, and I'll show that to you shortly. But of course, ensuring that the Arduino is connected to the virtual machine, and there's a green LED here that you can see that. So I'm just establishing a serial link using ROS serial between my Ubuntu machine and my Arduino. So those are the two processes that I need to run first. Now I'm going to actually generate a keyboard teleop interface. So it's this ROS run a teleop twist keyboard. You may have to install this package if you want to use this on your VM. So it's a sudo apt-get install ROS melodic teleop twist keyboard. So if you search this, you'll find this package. So right now it's waiting for command velocity. So a node to publish command velocity, which is currently not happening. So we'll come back to teleop. So this is my custom script. So Lab3 Corpella scripts. So I'm just running a custom script that I wrote, and I'm just publishing command velocity. I'm receiving command velocity, and then I'm publishing on servo channels to receive or to send the appropriate steering and throttle commands. So now with most everything running, I'll show you my list. So my node is publishing, is receiving command velocity. So it's subscribing to command velocity, and then I'm also sending steering and throttle commands to the Arduino through ROS serial, and I'm receiving ultrasound, which is the ultrasonic sensor that's currently on my device. So those are all of the topics that are available. In this window, I'm simply showing the ultrasound return, which provides a timestamp and the minimum maximum range. So the way that my device is set up, I actually have it's hitting the wall, and it's at about 1.78 meters from the ultrasonic sensor to the wall. So that's really the only requirement, is just to demonstrate that range works. This is my custom script, which is receiving velocity commands and then sending out throttle and steering. This is simply a keyboard teleop script that's freely and available. And then what I'll do also just run our QT graph just to show everything that's happening. So it's actually quite a bit. So here you can see R2 key graph. So again, teleop twist keyboard. So with keyboard input, and again, it's set up. If you have a gaming system, right? It's just generating linear and angular velocity. So that's all the teleop twist keyboard is doing. So that is publishing over the topic called command velocity, and then my script actually has. The node is called command velocity listener, so it's just listening for those velocity commands and then generating appropriate steering and throttle inputs to the Arduino to control the vehicle. So again, this could be servo 1, servo 2. Your naming convention is whatever you want to name it. The serial node is ROS serial, so that's handling the communication between Ubuntu and the Arduino. What the Arduino is also doing is it is publishing on the topic ultrasound. So that topic is then just being echoed in a terminal window that I showed you earlier. So that's our QT graph, really everything that's happening with the system. And then if we look, I can go back to teleop, and then my script actually wants velocities faster than 1 meter per second. So I'm just going to use Q to increase the speed by 10%. So this should be plenty speed. So now I'll switch back to my vehicle. So here's my vehicle setup. So serial cable to the Arduino, right? And this is getting powered from the Arduino. So 2 servo channels. Here are the 2 servo channels, pins 9 and 10. I'm just jumpering those over to this PCB board. And again, all I'm doing is sending signal and ground. I'm not powering the vehicle. So do not power the servo channels because they're getting power from the actual vehicle itself. So again, so just power and ground, and these could be you could just hook up, regular servos for testing. Channels 9 and 10, right, are my 2 servo channels, and then again, those are going to the steering and throttle on the side of the vehicle, right? So this is just, negative is ground, positive is power, and S is signal. Do not connect power to this. So simply, I'm just jumpering power and ground. And then the last piece, I am providing power, ground, and my analog signal. So on the Maxbotics the ultrasonic sensor, this is ground. This is power. You do have to power this device, which is this red cable here. And then this orange cable is the 3rd pin from the right. And then that's connected into A5. So you see A5. Then you see power and ground. Pins 9 and 10 for my 2 servo channels. Okay, and then finally, here's my keyboard. So I'm going to be pressing keys. And then I'm also... I'm just displaying the velocities on the screen, so I'll just show you real quick. So if I hit forward, I go forward. If I hit backward, I go backward. If I hit left, I go left, and if I hit right, I go right. And again, this is not the best solution, but this is the solution for full credit for this lab. You can scale how far or how fast you're going. I'm just using simple angles to represent I've got a linear velocity or an angular velocity. So with that, that's the demo.